And we're going to be looking at a few different examples of situations where learning should happen. For example, like if you could ask Pavlov, hey, should learning happen in this situation? He would probably say yes. But in reality, it looks like it doesn't happen. So these are situations where the early theorists all would have assumed that there would have been classical conditioning, and instead there wasn't. So the first one we're going to look at is something called latent inhibition. Now, unfortunately, this is a really bad name. It's not latent, and it doesn't involve inhibition. What latent inhibition is something that we've experienced many occasions. It basically describes the fact that most learning happens, most of our associations develop in our first few encounters, or in the very first encounter between a conditional stimulus and an unconditional stimulus. So there's something important about novelty that helps drive learning. And the latent inhibition part is that if there's a stimulus that's been around a long time that's really familiar, in other words, it's not our first encounter with it, we tend to ignore it. So we would tend to ignore a neutral stimulus like a beep or a sign. So it's something that could be a conditional stimulus, but it's never been paired with an unconditional stimulus. So it doesn't have, doesn't predict anything important happening. And in those cases, we really tend to ignore that kind of a stimulus. So as an example, what if there was a beep that just kind of went off, regularly during the day where you worked? It kind of went off randomly. It didn't really mean anything. You didn't have to do anything in response to it. Would you react to it after a few days of hearing it? I bet you would probably start to ignore it. Now, what if after working in this business for 6 months or a year, the same beep that you've been ignoring all this time started to signal that a delivery person was waiting for you by the loading dock? Would you suddenly be able to associate that beep with the loading dock? It turns out that in this situation, it would be really hard to now make that connection between the beep that you've been ignoring for 6 months or a year and the fact that it's telling you that there's a delivery person in the back of the store now. It would really make it hard to make that connection. So that's what latent inhibition is. It's that it's hard to make that connection or association with a stimulus, a CS and a US, if that CS is something that's been around for a long time and we've kind of gotten used to it and kind of have learned to ignore it up until now. Signs on the freeway are another example of this. They might warn us about construction up ahead, but we've all lived somewhere and we drove past these signs sometimes that are up for months, it seems, but there's no construction. At first, you see the sign, you're like, oh, okay, there's going to be construction, but there's not that day, there's none the next day, not the next day, and weeks and sometimes even months go by. In this case, think about how much people really slow down when they see the signs every day, but there's no construction. We pretty quickly figured out that there's not really going to be construction, and we tend to ignore the sign and drive 65, 70, and we don't slow down to 55, for example. Now, when construction finally starts, it's hard for drivers to remember to slow down when they see the signs because they've learned to ignore them for, a long time. And this points to the issue that attention is an important part of classical conditioning. So latent inhibition and this inability to associate a CS with the US if we've already learned to ignore that CS is best explained by how the US, the unconditional stimulus, can lead us to pay attention to a CS. It's not explained really well by the Rescorla-Wagner model that we saw in part 2. The Rescorla-Wagner model doesn't consider the prior history of a CS. The Rescorla-Wagner model takes into account, like, did the CS come before something that surprised you? In that case, you would learn something. Did the CS happen but there was no US, in which case it would sort of weaken the association? Or did the CS predict the US perfectly, which means you've already developed an association and there's really nothing new to learn? It only considers those three. It doesn't take into account the prior history like latent inhibition does. Now the next thing we're going to look at, that's another example of an association not developing, is something called associative bias. And basically, we can think of associative bias as saying that not all stimuli, not all CS's and US's can become associated together in an equally well way. there's some bias that some stimuli seem to go together and become associated more easily than others. And so let's take a look at this. And you're going to get a little bit of a history lesson, not too much, but in the 1960s, there was a psychologist working for the Navy, John Garcia, and he was studying the effects of X-rays in rats. And he noticed that the rats who were exposed to X-ray radiation had stopped drinking water when they were in the experimental chambers where they received the radiation. So the way it worked was he took the rats that lived in their normal little cages with glass water bottles, and he would pick them up and put them in these different cages to study the effects of radiation. And while they were in these different cages, they had plastic water bottles that kind of, I guess, had a little bit of a different flavor. And so he, John Garcia noticed that they stopped drinking this water, but only the water from the plastic water bottles where they got the radiation, and they drank normal amounts of water in their home cages, their regular cages. So he reasoned that the rats learned to avoid drinking the water from the plastic bottles in the experimental chambers because they got sick from the radiation after drinking water. And so this is called a taste aversion. It's a really common thing for humans to have. My story is when I was a kid, I remember being on a boat with my aunt and my cousins and so on, and I had never really been on a boat before, and I had also never had egg salad sandwich before, but she made an egg salad sandwich. Again, this is just not anything that my mom ever made or that we ever had at home, but my aunt made us egg salad sandwiches, so I had my first ever egg salad sandwich and then got on the boat, and I get very seasick. So I got really seasick, and ever since then, the sight or smell of egg salad just really makes me feel a little queasy. So that's kind of a very typical taste aversion. Some people have taste aversions to, say, tequila, or they might have a taste aversion to some particular type of food or something, but it's a really common thing. And it's really similar to what Garcia discovered with these rats, where you eat or drink something that's relatively new, so it has to be something new. So if you've been eating bread your whole life, you're probably not going to develop a taste aversion to bread all of a sudden if you get sick. But so it has to be something that's relatively new. And then after you eat this item or drink it, you get sick. Now, the food might make you sick, but you could also get sick because you got on a carnival ride that, spun you too many times and made you sick. Or in my case, I was on a boat that made me sick, or you could have had the stomach flu. So the important thing is that your brain is sort of associating or connecting the stomach sickness with this thing that you ate, because in general, if you do eat something and afterwards you get sick, it's probably best to avoid that thing, because if the item you ate is bad or you're allergic to it or it's poisonous, you really don't want to ever eat it again. And so that's the idea of a taste aversion, that it has some survival benefit because it's going to help you avoid food that might make you sick next time. So Garcia wanted to follow this up, and he was interested in whether he could train rats to avoid not just like the taste of a water given to them in an environment where they got sick, but maybe to some other stimulus. Like in his case, he looked at light and noise. So he looked at these two different types of CS, light and noise versus a sweet taste. So for the light noise, whenever the rats were going to drink water, a light would turn on and this noise would sound like a beep, and that would happen while they were drinking water. In another condition, another group of rats might drink water, but that water had a sweet taste to it, and it wasn't just plain tap water, right? So now it's a flavor that they're experiencing. So the conditional stimulus was either the lights and noises going off when they drank plain water, or the sweet taste of the sweetened water. And then what came afterwards is the unconditional stimulus, and that unconditional stimulus was either shock or lithium chloride. So let's look at these two. Shock obviously affects you on your skin. You feel it on the outside of your body, and it's really, it's painful and unpleasant. But it's brief, right? It's like they just got I think a second of shock or a few seconds of shock. It was lithium chloride, on the other hand, is a type of salt that if injected, or if it's ingested into by a person or an animal, it'll make you sick. So it just kind of makes you sick to your stomach. So here we have an unconditional stimulus that is something that definitely we react to, but in totally different ways. Shock is like an ouchie on the skin, whereas lithium chloride makes us feel queasy and sort of sick to our stomachs. And so he had 4 conditions. The rats either drank water, plain tap water, while the lights and noise went off, and then they got shocked, or they got sick to their stomachs because they got the lithium chloride. Or they had the sweet tasting water and either got shocked or got the lithium chloride and got sick. And what he found was when he gave the rats a chance to drink again, the ones who were shocked avoided the light and noise. So there's this connection between the light and noise and the shock. They definitely made that connection. However, the animals that got shocked after drinking, if they drank the sweet tasting water, didn't make that connection. They kept drinking that sweet tasting water even though it was paired with shock, just like the light and noise water was. So here there's like a difficulty in developing this connection between an internal thing like the taste of something and an external sensation like the shock. Now let's look and see what happened when the unconditional stimulus was lithium chloride, something that would make you feel kind of sick to your stomach. If that sickness of the stomach was paired with light noise, there was no association and the animals drank normally. They didn't avoid the light noise at all. In other words, there was no connection made there. But the ones who got sick to their stomachs definitely made a connection between that and the sweet taste. So the lithium chloride definitely led to an association with the sweet taste. So taste can be associated with sickness to your stomach, but lights and noises could be associated with shock, but you can't mix and match those. It was an important experiment because it really proved definitively that Pavlov was wrong on some of these counts, that you really could not connect or pair any two stimuli, any CS and any US, and expect an association to happen, that there was something else going on that was kind of important. Other studies have also shown a really special relationship between taste and illness, and showing that just how powerful that ease of developing association is. So Holland did this study, and involves 2 phases. Basically, the first phase is just an association between a particular taste, like strawberry flavored water, and a tone. So when the rats drink their strawberry flavored water, they might hear beep, and that goes on over and over and over again enough times so that basically you're just having this, creating this association between 2 neutral stimuli. In the second phase of the experiment, they take that same sound, that tone, and then they make the rats sick. So they give them lithium chloride, which makes them a little queasy to their stomach. They then give the rats the choice of drinking water with that taste or drinking from a water bottle that makes the tone sound. Now, here's what's interesting. The tone is the only thing that was actually associated with getting sick, right? The taste never was. The results, however, were that the rats avoided the taste, not the tone. So the tone is the only thing that's directly associated with the illness, but because the tone is associated with taste, the rats will sort of blame the taste for it, even though it was not directly associated with it. Until these studies were done, psychologists were looking for laws of learning that applied to anyone and anywhere. They were looking for what they called general laws of learning. And with these results and other similar results, the focus for research on learning was to look at the organism and its individual needs, how classical conditioning could help it survive and reproduce and so on. So really kind of looking at how classical conditioning functions and how it helps animals do better in the whole survival and reproduction arena.